Hello everyone. I'm going to, in this session, talk about scaling your pods in your Kubernetes cluster. For that purpose, we are going to deploy an nginx deployment, and then we are going to create a cluster IP service that gets the traffic and redirects the traffic to our pods. And then we are going to install metric server in our Kubernetes cluster, as by default it's not installed. And then we are going to use metrics to define a horizontal autoscaler rule. Okay. So to start, let's create a namespace to work with. My web app. Perfect. And then I'm going to create a manifest file. Let's call it nginx deployment.yaml. Actually, I have a template for nginx deployment, so I'm gonna just use it. Copy and paste here, but let's actually change some of the properties that we have in this file. So we need just one replica for now. Let's comment out limits and of course CPU, and let's reduce the CPU requests to 100 millishares. Okay, perfect. Let's save our file. And before applying this, let me actually change our current context so we don't have to mention our namespace every time that we want to execute command. So kubectl config set dash context dash dash current dash dash namespace my web app. Okay, it's been modified. kubectl get all, so of course our namespace is empty. Now let's apply file name nginx deployment and kubectl get all. As you can see, we have created this deployment, which has created this replica set for us, and this replica set has created a single pod that is running but not yet ready, but it will be soon. So let's as well create a cluster IP service so it can get the traffic and redirect the traffic to our pods. So kubectl create service cluster IP, and let's call it nginx cluster IP SVC. Let's use the TCP switch so it gets the traffic on port 80 and redirects the traffic on port 80 to our pod. So basically, the first port is the port that is being used on the service, and the second port is the port that is being used on our pods. And we could also set the cluster IP manually, and let's do that. 72, 20, 22, 148 would be okay. Okay, we've created, we can see it here. Service nginx cluster IP service, and this is the IP address. But we also need to set a selector for our cluster IP service. So let's do that. Set selector service nginx cluster IP SVC, and if I go here, you can see that we have two different labels in our deployment. We can use both of them. Actually, I have a dedicated dedicated label for my load balancer, so I'm gonna use that. So load balancer equals nginx cluster IP, okay, nginx cluster IP svc, okay. Now the selector has been updated. We can describe our service. Actually, I have just one service. I'm gonna use services. So you can see that we have an endpoint in our service, and that means if we ping this IP, not ping, but I mean send an HTTP request to this IP, it will redirect that request to this IP address, which is the IP address of our pod on port 80. And let's actually see that and confirm that. kubectl get all -o wide, and as you can see, 23.144 is actually the IP address of our pod that is running and ready now. Perfect. We have deployed an nginx deployment, and we have created a cluster IP service. So if let me clear the screen, if I use the HTTP command to send an HTTP request to the IP address of my cluster IP service, we should be able to 148 if I'm not mistaken. Yes, we should be able to redirect the traffic to our pod. Perfect. Now let's install the metrics server. kubectl, let me show you my namespace. Kube system, that it's actually that the metrics server is not installed by default. As you can see, I have no metrics server. Let me clear this. And so to install metrics server, you could search it on Google, and there's a GitHub page. You can simply read the installation section, how to install it. If you have your Kubernetes cluster on cloud, Amazon Web Services, you could just simply copy and paste this command. But because we are having our cluster on-prem, we need to actually specify the switch, okay? Because the kubelet certificate needs to be signed by cluster certificate authority, and so our Kubernetes cluster is installed on-prem, so we need to use this this switch, and for that purpose, I am going to actually get this YAML file, which is the deployment file, and I'm going to actually download it. Let's save it in my downloads folder. Let's open this with text editor. Okay, let's copy this, and here let's create a new file. Let's call it metrics.yaml. Okay, and let's paste it here, and let's add that switch to our file. Okay, I'm just gonna copy and paste it quickly. And don't forget to set it to true. Perfect. We are ready to go. Okay, kubectl. Now we can apply this. File name metrics.yaml, and by default and automatically, this is going to be installed in your kube system namespace, and so you don't have to mention it. kubectl namespace kube-system get all, and we can see that we have a new deployment metric server, we have a new replica set metric server, and we have a new pod that is created by our replica set. It's not yet ready, but it will be ready soon. Now now that we have actually installed metric server, we could use the top command. Okay, so kubectl top nodes. It will show my Kubernetes cluster that I just have one node that is working as master and worker node. I could use as well top pods, and it will show my pods and how much resources my pods are utilizing. Okay. Now that we have installed our Kubernetes metric server, we can actually create a horizontal autoscaler rule. Okay, and for that, let's use kubectl command again. Autoscale. It's super easy actually. Autoscale. We need to mention our deployment's name. Deployment. I believe it was nginx -deployment. Or we could use as well the file name, you know, and then specify our nginx deployment file, YAML file. But I'm going to use the name of our deployment here, and you would want to use the CPU %switch to specify. Well, I'll explain later. Okay, you could use the minimum switch and say minimum pods that I want this deployment to have is just one, and the maximum number of pods I'll set to, let's set it to 8. Okay, Autoscaler has been created for us. We could see it. As you can see, we have a horizontal pod autoscaler, and minimum pods is set to 1, and we already have 1, so we are hitting the minimum condition, and then maximum pods is 8, and then we have a target that we set for CPU % to 50. It's 50%, and I will actually explain it later. Let's create some load on our pods, so we can see how this autoscaler actually reacts to this load. Okay, so for that purpose, I'm going to create an Ubuntu image, and then I'm going to install Siege, and using Siege we're going to create some load and redirect that load on our cluster IP service that is redirecting the load to the traffic to our pods. Okay, so let's use the command run image Ubuntu. Perfect. Standard in and TTY for interactive, and let's call it, yeah, just simply Ubuntu. Okay, it's been created for us. Let's update our list of repositories. And let's install HTTPIE as well as Siege. Perfect. Let me open a new terminal and connect to my host. To my master node. Okay. as you can see, our pod here is just using 1% of the CPU request that we set for it when we deployed this deployment. So if I go here, nginx, you can see that we set 100 millishares, okay, and it's using 1% of this 100 millishares because, well, it's sitting there and doing nothing. So this 50% means if the average amount of CPU utilization by all the pods inside my deployment, because we have also a reference for our Autoscaler, if the average amount of CPU utilization by all of our pods is above the 50%, this Autoscaler is going actually to tell our deployment to deploy a new pod, okay, so that the average amount of CPU utilization drops below our threshold that we have set here, okay. So let me as well here run the top command again on our pods. So as you can see, we have one pod in our deployment, and it's using 1 millishare of our CPU. Okay. Now let's excuse me. Now let's using the siege command. Actually, let me show you that we can actually, because I have installed core DNS, we can use our service name, http nginx cluster IP SVC. We should be able to reach our pod. Okay, so we can use also our cluster IP service name. So I'm gonna use siege, and then I'm going to use the same name, nginx cluster IP SVC. Okay, and now it should create some load for us on our pods. And if I run get all command, we will see that now CPU utilization is hitting more than the target. It's 52 actually. And let me get top pods. As you can see, our pod is using 214 millishares of our CPU, which is way above the 50% of 100 millishare that we set in our deployment configuration file, right? And because we have this autoscaler rule, this autoscaler should see that the CPU utilization is much more than 50% that we have set, and it should tell our deployment to create more pods so that the average amount of CPU utilization drops below 50% or 50 millishares. Yeah, let us see top pods, and as you can see, there are pods that are being generated. They're not yet ready, but they will as soon as they are ready. Our cluster IP service is going to use them as endpoints to send traffic to them. Okay, they are ready now, and soon they should load balance the traffic between themselves. Okay, and as you can see, we have 5 different pods now, and these pods now each are using 50 below 50 millishares of our CPU. Okay, which is what that we want, right? As you can see, it's load balancing our service. Our cluster IP service is load balancing the traffic between them. And now we have 5 different pods, and each of them is using below 50% of their CPU request, right? That we had set in our deployment configuration file. And if I get all, you can see that now this amount is basically the average amount of all of these utilizations, and it's below 50%. So it's not gonna create any more pods for us, but it's gonna just be the way it is, unless I actually close this session, close our cancel our node, and then we should see that the load should drop. Oh, you know, I just closed the session, but not. No, it is actually dropping. Okay, you can see that the Ubuntu now is 0. There's no load on our Ubuntu, which was creating the load. And yeah, soon they are way below the 50%. And so these pods will be removed in a couple of minutes. That's it. I hope it's been informative for you, and I would like to thank you for viewing.